All right, everybody. Not gonna lie, it's the second time I've taught this lesson today because the Nearpod is not the best platform for what we're doing today, but that's okay. Figure it out. We're flexible. All right, we are starting 5 this week, and I'm super excited about this because I love astronomy. I know this is a testing week, so a lot of us are out of the classroom this week, but this is a great start to our astronomy unit. Okay, we have 2 units in astronomy. All of standard 1 is on astronomy and energy. Okay, so 1-1, we're still looking at the transfer of that energy. Well, how does that relate to moons? That's what we're doing today. Well, a moon doesn't shine of its own accord, right? So it has to reflect that energy from the sun and light energy. So that's why that matters there. And then we're also looking at motion of orbiting objects. Why do we have phases of the moon? Well, we have phases because an object is orbiting Earth and reflecting that light, the moon. Take a look at this model of the moon. And I will tell you, okay, we only see one side of the moon. Some students are really baffled by that, but we only see one side. In our night sky, we see the same side of the moon every night. And you could tell like they are vastly different. Look at the sides of the moon here. One side is vastly different than the other, if my mouse will work, okay? One side is vastly different than the other. Why would this side, the side that faces Earth, look less marked, less major craters? Okay, we have the Maria that's there. Those are the dark spots on the moon. El Mar, Spanish, that means sea. And so those are kind of coined the seas on the moon, those dark spots. But the man in the moon, that's Maria. This is the side that faces Earth. Okay, I want you to bring to class your thoughts on why the side that we don't see of the moon looks so different, looks so rough. Why do you think that's the case? Bring that to class. Okay. When you look in the night sky, I'm sure that you have been cognizant enough to go outside and see the faces of the moon at some point, right? And you probably studied this in 6th grade, maybe even a little bit in 8th grade. So this not new information, right? We've had some phenomenon here lately. This past year, we had a partial eclipse, which has to do with the moon, and we also had a total a couple of years ago, right in our area in the upstate, right? And so this is familiar, I guess, familiar territory for most of us. Rotation and revolution is something that you got to get under your belt before we can move further. Everything is spinning in space and everything is revolving in space. That's due to gravitational pull, due to mass and gravitational pull. Without getting too much into the math of that causes everything to spin, inertia as well, and revolve. Okay, so does the moon rotate? Does it spin? Yes, it does. It does spin. It spins on an axis. Okay, does Earth spin? Yes, once every 24 hours. Does Mars spin? Yes, once every 25 hours, if I'm not mistaken there. Does Mercury spin? Yeah, Mercury spins really fast. Okay, does Neptune spin? Yeah, Neptune spins, but its day and night are way long. So it does spin on an axis, okay? The moon does spin. Does the moon revolve? Well, yeah, of course. Moons revolve around their planets as planets revolve around the sun. So the moon does revolve, and it takes one whole month, that's why we call it a month, for the moon to revolve around the Earth. As it revolves, it reflects different amounts of light. And that's really what we're going to talk about today. But we got to understand the speed at which the moon revolves and rotates. And this is a great visual of what's actually happening. So we always see the same side of the moon. That's going to appear red. Okay, so if it doesn't rotate, can we still see the same side of the moon? The answer is no. You're seeing all sides of the moon there. So if it does not rotate, you see red still facing to the right of my screen. If it doesn't rotate, it can't be true because we see all sides of the moon. What about if it rotates too fast? If it rotates too fast, do we see all sides of the moon? Yes. So is that true? No. We only see the red side of the moon. So how fast is it rotating? Okay, this is called synchronous rotation. The moon is actually rotating at the same speed as it is revolving, synchronous rotation. It's kind of like if you were kids and you get out in the yard and you cross your hands and you hold your hands with another kid and you spin around and around and around. Earth has the moon locked in place just like that because it's 283,000 miles because it's close, right? Earth's gravitational pull has it locked in place. And so it's kind of grabbing the face of the moon and carrying it with it, all right? That's why we see just that red side. Why is that important to phases? Let's find out. What if we add a sun to this diagram, okay? And then I'll show you. Two things have to be true. For us to see a phase in our sky, it has to be the visible side and it has to have light. Two things have to be true. Okay? It has to be the visible side, the red side, and it has to have light. And whatever two things, whatever amount fits those two criteria, that is our moon phase. All right? So let's take a look. Also to note, the moon revolves counterclockwise. Okay? And I always say, I mean, it's easier to think about this as a clock. So if the sun is always 12 o'clock, that'll make it easier for you, okay? So here we go, okay? Now we're a quarter of the way there, right? And we've got this little sliver. So how much of that, what percentage would you give that, right? That little sliver is red and has light. I'd say that's about 25%. Okay, let it go a little bit further. This is actually one full quarter. Okay, and that's about 50%, right? So about 50% of what's visible has light. Okay, and that's a 50% moon. I don't get into the phases just yet. There's a bigger moon, right? So we're growing. We're seeing that red side have more light as we move through the revolution here. That would be maybe a 75% moon. Okay, and then we here straight up we have a beautiful full moon, right? 100% of what is visible has light. And then we start our trek back down. We can't go more than 100%, right? We start our trek back down, and look, we have another 75% moon. So 25, 50, 100. Now we're going back down to 75. And you guessed it, to 50%. And then our little sliver right there, our 25% moon. And then all the way back to the beginning. And I didn't say this when we started, but 0% is visible and has light here. Okay? If you were on Earth looking up, you would not see a moon in your night sky. All right, so how do we do this? How do we navigate these diagrams? There are two major diagrams that you'll see on tests. Okay? How do we navigate these diagrams? I'm going to give you some steps. Step one, half of everything is light, half of everything is dark. Due to gravity, gravitational pull, collisions, things like that, most everything in space is going to be round, especially your gaseous stars and even galaxies are more moving towards more round. So the older the galaxy, the more flattened and circular it will be because gravity's had time to pull everything together. So half of everything is light, half of everything is dark because obviously Earth is orbiting around the sun is in the middle, okay? Step two, we're going to add the moons counterclockwise. That should say revolution. Step three, we're going to add a little bob on Earth so we can look at what the perspective would be. Step 4, we're going to identify if it's increasing or decreasing. We'll give those terms just a minute. We're going to identify percentages in step 5. That should sound familiar. And then step 6, we're going to name those phases, okay? So walk through this slowly, and I promise you'll never miss it. Step 1 is to make sure half of everything is light. Sun's over here in this diagram. Remember, that's going to be our 12 o'clock. Okay? Half of everything is light, half of everything is dark. Well, what half is going to be colored in? Hint, hint, the half not facing the sun. Right? The half not facing the sun is going to be dark. Yes, forgive my drawing. Like I said at the beginning, your pot is not as functional for this as I was hoping. And my Jamboard blew up. So, all right. So what half would you color in on each of these spherical objects? And I really hope that you said the left side, because that's the side facing away from the sun. Okay. So we're going to color that in. I know my drawing's terrible. Bear with me. I am doing this with a mouse. I know, it's so archaic. I do have a drawing pad over there, but y'all can't figure out how it works. Okay. A little tedious, but that's all right. Half of everything is light, half of everything is dark. So we got all of our little moon phases, okay? Now let me say this. I know. I just want to make sure you understand. There are not 8 different moons. We have 1. But these are the different phases of, or different places in revolution of the moons, of the moon. Okay, next we're going to add the counterclockwise revolution. That's what it should say. Okay, so we'll have 9 o'clock here. This will be 6 o'clock, 3 o'clock. Okay, and we are orbiting, the moon is orbiting counterclockwise. It is also rotating counterclockwise, but that's neither here nor there. That is an error, typo. Step 3, we're going to add Bob. All right, now this is where it gets a little bit difficult. Actually, it's the only difficult part. Bob, let's draw Bob. Not just Bob, but Bob's perspective. What does Bob see in the night sky? So we're going to start here. Here's Bob. Hey, Bob. Terrible, I know. All right, Bob's looking up at the night sky, just like the red side of that moon in that video. What half of the moon is visible from Earth? We're going to draw our line of visibility. Okay? Ooh. Draw our line of visibility there. And you can see that of what is available to Earth, what is visible to Earth, none of it has light. So it has to fit our 2 criteria there. Okay? So that's what Bob sees in that sky. We'll continue to move Bob around the world here. Draw Bob over here. Why did we change colors? I don't know. Okay, Bob's looking up at the night sky. What half is visible? You can see that half is visible there. And now we have something. Now we have something. Now we have our criteria met. Okay, so we have the visibility and we have, that is hard to do, and we have light. We have the visibility and we have light. Okay, Bob here, looking up at the night sky. What half can Bob see? Good. Also, probably should turn my treadmill off. That might help with drawing. Add a Bob here, looking up at the night sky. Okay, that's kind of the line of visibility. Let's go ahead and do that again. Okay, and as you can see, if you do this correctly, you should almost be able to connect your lines of visibility and make a circle. And I'll tell you that because a lot of kids will just mark with the shaded area. And if you do that, your lines will be all wonky. Okay, so there's Bob. Bob's now just an X because my drawing stinks. And that's the line that he can see. There's Bob, and that's the line that he can see. Bob, what he can see, and Bob, and what he can see. All right, so now we've got our visibility. Look how they all connect. See that? Always double check your lines when you're doing something like this. Step 4, identify what half of the revolution is increasing and what half is decreasing. So let's go ahead and take a look at that. I'm going to get a little bit more crayon there. We can see that there's nothing here at 12 o'clock, but we got a little sliver there between the 12 and the 9, and we got a little more here, and we got a little more here, and I'm sure you're thinking percentages already in your head, right? And then we can see all of what is visible. Now we can't get better than all, so at this point we have to start going back down. But we can't just go from 100 to 0. So that is what is visible and what it has light. What is visible and has light. What is visible and has light. Now let's give it some percentages. Step 5, percentages. Okay, what percentage would you give? Let's do text. What percentage would you give this new moon? Well, 0% is visible and has light. So we're going to say 0. I don't really know why it's not doing it. Just go with the crayon. All right, so 0% moon. We got here, you got a little sliver, we'll say 25% moon. Here we got a little bit more. It is 50% of what we can see. Here you got a little bit more. It is 75% more than 75% of what we can see. This is our 100, our nice big beautiful full moon. And then we have to go back down. So 75, 50, and 25. And those are our percentages. Well, why do percentages? Because I think it helps students relate to what the names are. Okay. All right. So we have what we have on this top half. Okay. What we have up here, everything above that line I just drew, we're going 0, 25, 50, 75, 100. Is that increasing or is it decreasing? Hopefully you said it's increasing, going 0 to 100. We call that waxing. Like, yes, like if you're thinking what I'm thinking, or maybe I'm just way older than you, but Karate Kid, wax on, we say wane off. Wax on, wane off. So you'll notice this half down here, this half down here is decreasing, 100 to 0. 0 to 100 is waxing, 100 back down to 0 is waning. Wax on, wane off. Now, the last thing that we need to do, I know it's getting lengthy here, but the last thing we need to do is we need to name them. We need to identify them. Okay? So we're going to give these percentages a name. All right, let's see, 25. All right, a 25% moon. We call that a crescent. Sorry, there's a message. Crescent moon. Okay. Our 50% moons are interesting. This this messes up some people, but it helps more than it hinders. Our 50% moon is 1/4 or 3/4 of the way around the moon's revolution. And so we call these quarter moons. If it's increasing, we call it first. If it's decreasing, we call it last. So our 50% moon is a first or last quarter moon. And some people look at it and say, like, well, I see, it makes sense to me because that yellow part right there, that's a quarter. of what I see. That's a quarter of the pizza pie. Okay. If that helps you, great. But the reason it is called a quarter moon is because it is 1/4 around the revolution to that 9 o'clock and last quarter at that 3 o'clock. Okay. We have a 75% moon. Which is called a gibbous. I know that sounds weird, doesn't it? A gibbous moon. And then we have our 0 and 100. And we already know those. Those are new and full. Okay. So those are our moon phases. And now we should be able to name them. Right. So if we go to the top up here, we have to add, except for quarter moons, we have to put waxing and waning there, all right, and new moon and full moon. But because there are two 25s and because there are two 75s, we have to use waxing and waning to identify what they are. Okay, so this 25, this would be a new moon, right? Everybody's got that. This is new moon. If you've done this correctly, this one, because it's at the top, because it is growing, here's another one. Because the light is on the right, this is a waxing moon. And given that it is 25%, it is a waxing crescent. All right, we got this moon here. Next, we know that because it's a quarter of the way around the revolution and it is increasing, so it is the first quarter moon. For the 75% moon right here, we know that it's still at the top, so we have to identify it as waxing, but also we know that it is 75%, so it's a waxing gibbous. Full's pretty easy, right? 100% is a full moon. And then we go back down. Now, on this bottom half, there are two that we have to identify as growing or getting smaller. And that's your gibbous and your crescent, just like up at the top. Okay, so that's 75% moon there. It is the bottom half, so we have to identify it as waxing. I meant waning, sorry, waning. And if you're Bob, you're in this little X right here. If you're looking up at that moon, you will see that the light is on the left. Now we are going down. Light is on the left. So this is the waning gibbous. We are at our 3 o'clock here, so we know that this is a quarter moon. I mean, you think about that like a clock, right? 3 is 15. That's a quarter. 9 is also a quarter. I changed it yet. So this is the last quarter because it's decreasing. It's the last quarter of the moon's revolution. And then finally, we get back to our little sliver over here. Crescent, like a crescent roll. Those are good Thanksgiving. We don't get them any other time of the year, but super good Thanksgiving. And we know that the light is on the left. We know that this is going down. We know that light is decreasing. So we're going to say this is a waning crescent moon. A waning crescent. I challenge you to look out at the moon tonight. Okay, I don't know where we are in our phases, but see if you can understand light is left, light is right. Okay, and that'll help you. All right, this would be something 175%. I know I said you can't go over 100, but definitely screenshot this, my students. Put this in your Unit 5 study guide folder. Okay, let's take a look at a different perspective here. This is if you are on Earth. This is if you are looking at your night sky. Okay. Oh, wait, I want to go back. I do want to show you this. I want to identify this. Oh, it's gone. I love it when that happens. think I would have learned the first time I did this video, but apparently not. All right. So again, we're going to start with our percentages. Okay. 0%, 25, 50, 75, 100. Now we have to go back down. Don't get confused there just because 25 is above it. 75, 50, and 25. That really looks like 2, doesn't it? Okay. So these are our percentages. We're going to say 0% is visible. So 0% of what we can see has light. So this one, I'm just going to very quickly shade in. All right. We also know the 100, right? 100, that's easy. Good. We're going to just go ahead and color that fully in. That's our full. And those are the two of the easiest to immediately identify. So is a 50% moon, right? So let's look at how we do this sliver. Across the top, we are going from 0 to 75. Is that increasing or is that decreasing? Hopefully you said it's increasing, which would be waxing. Across the bottom, we're going from 100 back to 20 or down to 25. So we know that that is getting smaller or waning. And I gave you a key just a minute ago. When it's waxing, right is light. When it's waxing, right is light. Right is light. When it's waning, left is light. Okay? So let's use that to fill this diagram out. All right? 25% moon and the light is on the right. If you draw it like this, I'm going to lose my mind, my kiddos, because you don't see anything in your night sky that looks like the Cookie Monster done taking a bite out of that. Okay? Unless it's an eclipse. All right? So we're going to draw that sliver just like that. And shade in what has light. We know that right is light, so that's this side. Okay? The other side clearly would be dark. I'm not going to take the time to, well, yes, I will. Yes, I will. Let's be thorough. Okay? So this side will be dark. So we'd say our little crescent moon in the sky. This side over here, 50%, that's an easy one, right? We're just going to draw right down the middle. But light is right. Light is right. So we'll color in this side, but light is right. So light still on the right-hand side. Ooh, look a little squirrely. Okay. 75% moon. We draw our little sliver on the other side. 75% has light. Okay. And now we're up to 100. Now let me give you a hint for this. Whatever you draw on the top, draw the same line on the bottom. Just fill in the other side. Okay. So I drew my little line on this side up there. Down here, I'm going to draw the same line. I'm just going to reverse the color. Same thing, drawing the same line. Same thing, drawing the same line, just reversing my colors. Okay. So now we're at the bottom. We are decreasing, and left is light. Left is light. Sorry if y'all hear my dog whining in the background. They've all had a stomach virus. It's been super fun. 75%, 50%, 25% left is light. Okay. Now we can name them. All right. Our 0% moon we know is new. Our 25%, we know because it's 25, there are two of them. We need waxing or waning. We are at the top. Light is right. We are increasing. So it is our waxing crescent. Our 50% moon, light is right. This is probably the hardest one to get here with this model Okay, light is right, light is right. That means it's increasing. That means it's at the top. That means it's first. It is first quarter around the revolution. Then we have our 75% moon, 75. We need waxing or waning with this one because there are two. Okay, we're still on the top. Light is still right. We are waxing gibbous. Now we're at our big, beautiful full moon. %. Now we're going down. So we know we are waning. Because there are two gibbous, we need to identify it as waning gibbous. Okay, then we've got our quarter moon here. We've already identified the first quarter, so we know this one's the last. And then we've got our little crescent. We have to identify as waxing or waning. It is going down, light is left, so this is a waning crescent. Okay, you guys, you got to really practice these. Also, there are a couple of quick checks, and I'm going to show you. Everything that lines up here must equal 100. So if you look, 0 and 100, that's 100. Okay, 25-75, 100%. 50-50, 100%. 25-75, 100%. So if you've got something wonky, that will show you. Also, when we're looking at that clock that disappeared just a minute ago, when we're looking at that clock, notice that everything straight across is full or new. So it's all or nothing. And then your quarter moons, okay, are at that 9 and 3. And that'll really help us with tides, okay, because we got some special tides that follow those moon phases. All right, let's see if there's anything else. I think most everything else is on you guys. I don't think there's anything else for me to identify. Yep, the rest of it is just practice. And that'll be it for today. I hope you guys learned something. See you soon.